A ChatGPT query uses about 10 times as much electricity as a Google search. That difference is the catalyst for a new era of energy consumption, one where our evolving technology demands are now reshaping how the US and the world power our future.
Nuclear energy at a turning point, seeing momentum as power demand jumps from electrification and data centers.
Nuclear power and technology, or big tech getting involved in it. Nuclear power has sort of gotten back into the conversation.
We're going to be way ahead of AI, and we've got to produce tremendous amounts of electricity.
We're in the midst of a nuclear renaissance right now, and that's because power demand is meaningfully rising for the first time in a few decades. And at the moment, we just don't have enough clean energy options to meet that power demand from things like reshoring, electrification, as well as data centers.
This is why big tech is betting on nuclear power. Data centers around the world, built by tech giants like Amazon, Microsoft, Meta, and Google, are hungry, not just for AI training sets, but for energy. Artificial intelligence, driven by massive computing power, is reshaping not only how we work, but also how we think about energy consumption.
What AI did is it escalated the power demand at individual data centers by a factor of 10, or even 100 if we're looking forward into the future. That means those are data centers that are needing power along the same scale as entire cities.
The Department of Energy estimates global electricity demand could rise from a third to 3/4 by 2050, with the U.S. energy grid seeing an unprecedented strain. Data centers powering artificial intelligence and cloud computing will be among the biggest contributors to this growing demand. Energy use was already slowly ticking up, but oil and gas prices skyrocketed as energy powerhouse Russia invaded Ukraine in 2022, and geopolitical volatility was on the rise.
That's really when these dialogues started to happen again in earnest, the idea of what does energy security, what does energy independence mean, and that's when we saw countries start to look at nuclear once again.
As OpenAI introduced ChatGPT to the masses in November 2022, the buzz and investment around large language models put the US on a path to an AI future and the energy demands that come with it.
It wasn't the tech companies' problem to understand how electricity worked. They knew that they could build a data center, plug into the grid, and there was enough power. And then their marketing people made sure that they had enough renewable energy credits to claim that they're actually using renewables to power their data center.
And so really right now, everyone is trying to play catch up of how are we going to meet all of these power demand goals, as well as reduce our emissions. And so that's where nuclear comes into the picture. Solar and wind are great, but they're intermittent resources. That means that it's not always sunny, it's not always windy, so they aren't 24/7. And what nuclear is it's 24/7 baseload, emissions-free energy.
Major tech companies are leading the charge. Just last spring, Amazon agreed to a nuclear power purchase agreement with Talon Energy in Pennsylvania and bought the adjacent data center from Talon for $650 million. Now, Amazon is investing over $500 million into a number of nuclear power projects ranging from Virginia to Washington State. Microsoft is working with Constellation Energy to reopen the 3 Mile Island nuclear facility, with plans for $1.5 billion in upgrades there. Meanwhile, Bill Gates-founded TerraPower is also working on a plant in Wyoming. Then there's Google, who's working with startup Kairos Power to bring advanced reactors online in the next decade, though no dollar amounts have been announced for those investments yet. Meta also says it's looking into nuclear power, targeting 1 to 4 gigawatts in new energy capacity. But these investments and partnerships are becoming an industry-wide trend, all driven by a shared belief. Nuclear is the only solution.
The tech companies have a vision of the world based on AI. That world is only possible if they produce a large amount of clean, steady power. That's why their work into nuclear now is fundamental to whether their entire world vision can come true.
These are existing and retired nuclear sites in the US with space for new reactors. The next step in the sustainable transition is to design, build, and bring those new reactors online alongside the existing ones. Enter SMRs, or small modular reactors. Unlike traditional reactors, SMRs are smaller, faster to build, and more cost-effective. They produce around 300 megawatts of energy compared to the typical 1 gigawatt output of traditional plants, and their modular designs allow for off-site assembly, reducing construction costs and build timelines. Tech and energy companies are working to bring several of these reactors online over the next decade, as incremental steps toward a broader energy transformation.
You can assemble them at a factory and then bring them to the site for the final assembly versus having to build it from scratch on the location. And so that's what's traditionally been done with commercial reactors, and that's why they've often been very expensive. And so there's a lot of hope that with these smaller modular reactors that are about 300 megawatts, or even micro reactors, which can be tens of megawatts, that could kind of address some of the issues of these cost overruns.
SMRs don't operate much differently than traditional reactors, but the efficiency gains they do offer will be important for intermittently scaling our energy future.
Obviously, there's a role to build still some of these plants, but small kind of scales more naturally with how demand growth goes, especially when you look at the AI side and data center space. A lot of sweet spots are in the couple hundred megawatts in terms of total usage, but those are building up in dozens of megawatt chunks per time. So they themselves are modular. So the smaller plants really can match that growth more organically.
While SMRs hold promise, they're still a few years away. All plans in the US are currently slated to open in 2030 and beyond. Right now, there are no SMRs operational in the US, and regulatory approval will remain a challenge for years to come. There are also experts who say our nuclear solution should be a combination of these new, smaller output designs in addition to building more traditional commercial reactors.
While the SMRs are cheaper up front, they also provide meaningfully less power. And so while there's so much momentum behind SMRs, there are others that say we really need new commercial scale reactors to meet our energy goals and to meet our climate goals. And right now, there are no commercial reactors under construction in the US.
I think that for a country like the United States, the natural process, as we need an enormous number of large reactors, like that's how much power we need, is that SMRs will be a way to open up the conversation. SMR gives us a term that sounds like it's new and advanced, so it makes a lot of people a lot more comfortable talking about